Model-based definition, lecture 4. So we're going to be discussing the functional tolerancing and annotation workbench, also known as the FTNA workbench, and we're going to do a quick review of scenes, how to create a scene for your exploded view. Okay, so let's first take a look at your assignments from the past. So far we've done the angle bracket, the clamp assembly, the motor base assembly, the lifting assembly, which is extra credit, and we've done our drawings, right? So large aerospace companies, to get away from making drawings, companies like Northrop and Boeing, instead of having to pay one of their employees to create drawings, which is time consuming and can be expensive, what they do now is they instead provide a model with attached notes in 3D. Okay, this is referred to as model-based definition, and they use the functional tolerancing and annotation workbench to attach dimensions and notes. And again, this is to get away from providing drawings to a machine shop or a metal forming shop that you have contracted to do the parts for you. And finally, your last assignment, which we'll cover next week, is digital mockup. We'll be doing a clash report and a sectioning of a 3D model to check for anything clashing with each other. And this will be your last assignment. This is something you can probably do in about 20 minutes. Okay, so let's go back to model-based definition. Let's continue on with the lecture. Okay, so lecture 4, model-based definition. So let's see at some examples of actual model-based definition parts. This is something that I downloaded from the internet. So once again, these big aerospace companies, instead of providing you with the part and the drawing, they're just providing you with a part and annotations and dimensions. And when it comes to finding dimensions for parts that are not labeled, so for example, let's take a look at this tab. They didn't label this with a dimension as far as how long this tab is. So to find out what this dimension is, you actually open up the 3D model in CATIA and use your calipers to find this length. So let's say this length off the model is exactly 1 inch. But what's my tolerance? So the metal forming shop wants to know, hey, how much can I be off by? Because there's no such thing as a perfect part. You need some wiggle room for error. So this is something you would find in the documentation that the aerospace company will provide you. So not only will they provide you with the 3D model and all these attached FTNA notes, they will also provide you with the statement of work. And in there will be some instructions of what tolerance to use. So once again, if I measure this off the model, it says 1 inch. Hey, there's no tolerance, so I would have to go into the documentation provided by the aerospace company. And in there, most likely it'll say, hey, any features that are not dimensioned in the 3D model, measure it directly off the model and apply a tolerance of plus or minus 30 thousandths when dealing with inches. Okay, so if this is 1 inch, I can be off by plus 0.030. So this can be as long as 1.030. And it can be as low as 0.970, which is just 1 inch minus 0.030. So once again, the dimension is 1 inch plus or minus 0.030, or also known as 30 thousandths of an inch. Here's something that we have in metric, millimeters. Most of your dimensions will be either in inches or millimeters. Okay, so once again, you open up the model. And if you don't have a dimension, if you want to know a dimension, for example, maybe the height of this shaft, or maybe the thickness of this flange, you'd measure it directly from the model and apply whatever tolerance is included in the statement of work and the documentation. Now, if it deviates from the tolerance given in the documentation, then they would have to attach it to a note, or in this case, this dimension. They're telling us, hey, this shaft, this diameter, this is millimeters, is 50 millimeters, and you can be off by plus or minus 0.2. So the diameter of this shaft here can be up to 50.2, and it can be no lower than 49.8. Okay, so this tolerance deviates from the tolerance in the notes. Same thing with this one. They're telling us that this base plate has a diameter of 100, and when the inspector checks it, it can be as high as 100.2 or as low as 99.8. So this is 100 in diameter, millimeters, plus or minus 0.2. And we also have GD&T callouts. We don't cover GD&T in this class. That's covered in CAT 45. That's a class I recommend you take more towards the end of your CAT classes. It's not something you want to take up front. CAT 45 is a very difficult class. It's like learning geometry for the first time. It's like applying geometry to 3D models. All right. Now, I need to give you a warning. If you're using your CATIA at home, if you're using a CATIA license that you downloaded, a student license, and you're using it at home or at work, I want you to be aware of that you don't have access to the FTNA workbench. But that's okay. I'm going to show you a way around it. It'll be limited, but we'll still be able to attach some notes in 3D. All right, so if you're going to use the FTNA workbench on an assembly, so if you open up your clamp assembly, for example, and you want to attach notes, FTNA notes, then you will go to Start, Mechanical, Product, Functional Tolerancing and Annotation. So this is for assemblies. If you were just attaching notes, FTNA notes, to a single part, like the clamp strap, which I'm going to use as a demo, then we will go to Start, Mechanical Design, Functional Tolerancing and Annotation. And that's for a single part. And I'm going to show you how to get around that for those of you that don't have access to the FTNA workbench. Okay, so here's a part that I downloaded from the internet. Okay, so once you start attaching FTNA notes, you're going to see a branch start populating view frames, datums, GD&T, and text. Okay, so as you're attaching notes to your model, it's going to populate it, or it's going to include it in your CATIA tree. Okay, so we'll come back and discuss this in another example. Okay, so if you do have access to the FTNA workbench, if you look in the upper right corner, you'll see this icon, which lets you know you are in the FTNA workbench. And these are the commands you have access to. Now, if you don't have the FTNA workbench, it's okay because we'll still have access to a few of the commands here. Not all of them, but at least enough to practice our FTNA. Okay, so this icon, this is to create view frames. View frames in 3D. So what's a view frame? Well, if you go back to drafting, let's go to drafting. So if you go to drafting, anytime you create a view, it adds a frame. If you want to add text to a view, make sure the frame is active. It's red. You can either double click here or double click on the tree. As you can see, mine is already red. It's active. If you want to add notes, I'm going to use the text command to add some notes, and it'll add it to that view frame. So if I move this view frame, that text will move with it. If I wanted to add text to this view, okay, you would double click, and here is the text. Let's say this time I wanted to add a flag note, or I should say a text with a leader. I'm just randomly typing in numbers and letters, I should say. If I want to add text, okay, click on the T icon. That allows me to add text. And I'm just randomly clicking on any keys here. Okay, so now the text that we see here is attached to this view. So if I was to move this view, you'll see the text moves with that view. So we're going to apply the same principle here to our 3D model. We're going to add frames in 3D and attach notes to that frame. All right, so let's go back to the lecture. Okay, so we're going to be creating frames in 3D. So we'll be creating a front view, top view, side view frame. Okay, if you want to add notes in 3D, so text with leader, flag notes, your datums ABC. So your datums pretty much sets up your axis, like your XYZ axis, except we use letters A, B, and C for your datums. You want to add balloons, GD&T callout, GD&T frames, symbols. If you want to add dimensions with the rectangle around it, that's for GD&T, where you apply GD&T tolerance to the dimension with the box. We also have regular dimensions, diameters. And we also have capture views, which you can also import into a PDF file. And this icon, when it's on, it lets you know what your dimension, for example, if you were to attach a dimension to your part, and this is on, it'll light up the surfaces or the edges that you're dimensioning to anytime you click on that dimension, and I'll demonstrate that. All right, so for your assignment, for your FTNA assignment, you're going to use the functional tolerancing and annotation workbench. And again, if you don't have access to this, I'm going to show you a way around it. It'll be limited, but at least to get you your full credit. And I prefer that you use a clamp strap, but if you want to use a different part, if you want to use one of your other CATIA models to add notes to, go for it. Okay, so for your assignment, use a clamp strap or other part and apply notes, dimensions, tolerances as shown on the following slide. Note, you may use any CATIA part and apply any notes you like. Apply at least 10 notes to get full credit. Okay, so let's take a look. Okay, so I'm going to email you this PDF file. So to get full credit for this assignment, which is 100 points, you are to attach at least 10 notes to get full credit. So pretty much you're going to get 10 points per note. You don't have to attach the same notes that you see here. And again, those of you that don't have access to the FTNA workbench, you're going to be limited as to where you can attach. So this is just an example of what I want you to follow, but you don't have to follow this. All I need is 10 notes for you to get your 100 points. If you want to attach 10 flag notes, that'll give you your full credit. If you want to attach a note with the leader, that will also, if you want to do 10 of those, that'll get you your full credit for this assignment. Okay, so here's a model I created. This is something I did for my lecture, for my class during lecture 2 years ago. So I actually walked them through how to use the FTNA workbench. And as you can see on the tree, it creates, we can create captures. We can create view frames. So just like on a drawing, I know it's hard to see, but you see this little blue frame for the front view. And then we have this one which is currently active, which is the side view. And we also have a top view. Here's the frame for the top view. And I'll actually show you the real model. Okay, and I set up my datums. So datums set up your axis system. I applied some GD&T notes. Okay, so the notes you see here in the frame, these are GD&T notes. That's your tolerance. And we also have dimensions and flag notes. So let's take a look at the 3D model. Okay, so this is again something I created a few years back using the FTNA workbench. I did this for the lecture for my class. Okay, so let's take a look at captures. Okay, so let me zoom in here. I can click on the white branches here or click on the little white axis down here on the bottom right. And I can zoom in and out on the tree. And to get out of it, you can either click on the white branch or click on this little white axis to get you out of tree mode. Okay, so if you want to create a capture, let's go back to the notes. If you want to create a capture, you would use this command. Again, you need the FTNA workbench. I'm not going to ask you to create a capture if you don't have access to a FTNA workbench, but you would look for this icon. Sometimes you have to dig out the tool to be able to find it. Don't mix it up with the black camera, which is for studio purposes, like taking screenshots. This one's a blue camera, and this is for capturing in 3D. So let me show you what a capture looks like. Okay, so in the FTNA workbench, I was able to create captures of each view. So let's click on this first one, front view. So that's my front view, and it shows me all the notes associated with this front view. So again, here's the frame, just like in drafting, just like on a drawing. Okay, so that's my front view, and it's showing me my datum. So this is datum A. This is like similar to my x-axis, except I'm using a surface to define it. Okay, let's go to bottom view. So there's a bottom view. Okay, you can see the frame, and these are all the notes attached to that frame. This comes in handy when so the engineer that designs this part will create captures so that if you work in a machine shop, metal forming shop, and you need to give them an estimate and a time as to how long it's going to take to make this part and how much you're going to charge them per part, you can easily go through these captures, look at the tolerances, look at the GD&T callouts, look at the diameters, for example, your datums. So your datum set up your axis system. Let's go to another view. Oops, this one's mislabeled. This is a right side view. And there's the dimensions for the right side view. Okay, let's go to, this is an ISO view. This one's also mislabeled. ISO view. And finally, this is a view at an awkward angle here. You can see it's with respect to this frame. All right, so those are the captures. And let's talk about view frames. So again, view frames are similar to what we see on a drawing. As I mentioned earlier, if you want to add text to a view, make sure you first double click, make it active, and add text so the text is attached to that view and also to the view frame. Okay, let's go back to the 3D model. All right, so how do you create a view frame? It's very simple. To create a view frame, all you simply have to do is use our icon here. This creates a frame, and all you have to do is click on a plane or a flat surface, and it'll create that view frame. Now, once again, I don't have FTNA on my personal computer. This is a student license. But we do have the FTNA and part design. So we are currently in part design. As you can see, we are in part design. So I should have an simplified version of FTNA. And here it is for annotations. It's limited. Obviously, it doesn't have all the other commands as the FTNA workbench. We're very limited. But here's the view frame. Okay, so if you wanted to create a view frame, so you click on the view frame and click on any flat surface or plane. Click and it'll create a frame. You can give it a name. It's hard to see, but here it is. My new frame. It's collapsed because there's nothing in it yet. Okay, so you can give it a name here. I'll just let it default to that name. Hit OK. And here's my view frame. And again, it's tiny because there's nothing attached to it as far as FTNA notes. So let's say I wanted to add a flag note. Let's say I wanted to add a note saying, hey, in this area, we don't want any paint, but you can primer it. Or maybe don't primer and paint this area because it's going to mate up with another piece and we need metal to metal contact. So let's say we needed to add a note. And I click and watch this frame. Watch what happens to the frame when I attach the note. See how the frame moves and changes in size. You can see the frame changes in size as I move my note. Okay, notice when I click on this note, it doesn't light up the top, but if I turn on this option, this 3D annotation query switch on and off. So now when I click on it, it highlights what I'm pointing to. Okay, let's go ahead and add another note. So let's say I wanted to add, so that's 10 points, all right? So here we are attaching notes, right? Typically, actually you should always use capital letters when it comes to notes. So I'm gonna add some note here and say part number, etch, or scribe, I should say, part number, PN, part number. Okay, and as you can see, the frame will increase in size as we add more notes or spread out the notes, as you can see. Okay, so with this note, I'm saying, hey, I want you to scribe the part number on this surface. Okay, or I can pick another surface. Okay, so that's how you add a frame, and that's how you attach notes. Okay, so datums. Now again, I did this a few years back using the FTNA workbench. As you can see, we don't have datums as an option here. Okay, so if you wanted to create a datum, you would click on this icon to create a datum to set up your XYZ axis. In this case, our ABC axis. Okay, so in this case, I chose this as my datum A. And let's look at datum B. Datum B, as you can see, here's datum B, is the axis of this hole. And datum C, oh, it didn't come out right. Datum C is actually not this surface. Datum C is the symmetry line between this surface and this surface. There it is. Okay, so datum C is the halfway point between the walls of the slot. So in other words, my axis is at, I should say my axis is with respect to the axis of this hole. So my axis ABC is with respect to the center line of this hole. And it's laying on top of this center point of this hole. And it lines up, and its orientation is with respect to the slot. Okay, so that's my axis system, my datum, ABC. That's not important for this lecture, but that's how I set up my part. If you want, you can always set up your axis system at a corner if you like. In this case, I chose to set up my axis system for inspection with respect to this hole. All right, so once you add dimensions like diameter or length, you can attach frames for GD&T. Okay, for those of you that are not familiar with GD&T, geometric dimensioning and tolerancing, this is my tolerance for the location of this counterbore hole. So we have this hole and this larger hole, so referred to as a counterbore hole. Okay, so what I'm telling the machinist and the inspector is, hey, the axis of this hole, the center line of this hole, if I was to draw a little tiny circle around that imaginary center line with a diameter of 0.005, so if I was to draw this little tiny circle with diameter 0.005, the position of the counterbore hole can move around as long as it's inside this imaginary little circle. So imagine you have this little circle here, and the center line of this counterbore hole can float anywhere in that circle. As long as it doesn't fall out of that circle, then the position is good. If it falls out of this little imaginary circle, then the location is off, and The part is no good. All right, so adding dimensions. Okay, so I added an overall dimension. It's just a reference only. It's in parentheses, reference only. Okay, it's from this wall to this wall. And we also have flag notes or text with leaders. All right, so for your assignment, add notes. Again, you don't have to follow this. This is just an example of what to follow for your assignment. Okay, so I was able to do all this using the FTNA workbench. And we're going to come back and do some scenes. But let's go ahead and do an FTNA exercise just so you can get your 100 points. Okay, so I'm going to go ahead and go to my clamp assembly. And once again, we also have a limited in the assembly workbench. We also have a limited FTNA workbench, or I should say toolbar, just like the part design. So I'm going to allow you to either add notes to your assembly or to a single part. Okay, so if I wanted to add notes to this assembly, yeah, I'll start by adding a frame. Add a frame, give it a name, and you can start going ahead and just add notes. If you just want to add a simple note like scribe part number. If you want to add a flag note, flag note 1, okay. Okay, now if you just want to add text with no leader, so I'm going to add text in space. I'm going to say, hey, notes, capitals, use capital letters. I'm going to put notes, or you can put general notes. Okay, I hit enter. I accidentally exited my notes. Let me go back, double click. When you hit enter, it exits your window, your text window. I got to hit control enter to go to the next line. That's what I meant to do. So I can say, hey, flag note number 1. Do not paint. Do not primer. Maybe we need a bare surface there to make contact with another piece. So I'm just randomly adding notes, so it may not make sense what I'm adding. So I'm just randomly adding notes. Control 2, or I should say Control Enter to go to the next line. And just add some note. Okay, note 2, I'm just going to randomly add some babble here. Control Enter to go to the next line. All right, so you are going to have some general notes. Another good example is maybe the material. Control Enter. Hey, let's make this out of aluminum. Let's say 2024. 2024 aluminum alloy. And I can say T5, that's the temper. All right, so there we have it, 3 notes. That'll give us 30 points. Okay, so that's how you add notes in an assembly. Now let's do a FTNA on a single part. So I'm going to right click on the clamp strap and I'm going to open it in its own window. So notice it doesn't have the notes from the assembly. The assembly has a different FTNA notes. So these are notes now for the single part. Okay, so let's go ahead and add 10 notes so we can get our points. So I'll start by adding a frame. Add a frame. Okay. And there's my frame. I know it's hard to see, but there it is. There's my frame. Let's add some notes. So let's go ahead and pull out the FTNA, the limited FTNA. I'll add a flag note. Hey, I'll call this note 1. Okay, scribe. I'm going to go ahead and scribe part number. Very common note you see on a part. Okay, now I don't have a datum icon, so I'll just make up I'll use the leader with the flag note. And I'll just call the top surface my datum. Datum A. All right, so now let's say I wanted to do a side view. Okay, so I'm going to click on the frame. Let's create a new view frame. I'm going to click on this surface. And there it is. There's my view frame. Currently it's empty and it's active. It's red. We're going to add notes to this one now. Okay. Okay, so let's say I want to make this datum B. I'll make this datum B. I'm going to deviate from the earlier model. All right, so let's go ahead and add a datum, and I'll do it with notes and text and a leader. And once again, I don't have the datum icon, so I'm just doing it the long way here. Notice how my view frame increases with the text. And you know what? Let's say I wanted to do a top view now. Okay, so I'm going to do a top view. So I'll go ahead and add a frame. And this time I'll click on the top surface. And there it is. There's my view frame. So now it's going to add text on the top. Or viewing it from the top, I should say. Okay, so this is going to be our top view. And we're going to attach text with respect to our perspective from the top view. Okay, I'm going to call this datum C. Okay, I'll call this surface datum C. So let's go ahead and add notes. So I'm going to click on, oh, it didn't generate the view. Let me go back. I forgot to hit OK. So once again, let me go back, create that third frame. I forgot to hit OK. Okay, there it is. So there's my view frame. And I'm going to add text on this wall, and I'll call that datum C. And OK. And as you can see, it's giving me that text with respect from the top view. Okay, and from here on, I'm just going to randomly add some notes. Hey, just flag notes. Flag note 2. So we're still in the top view frame. So again, just so you can get your points, just randomly add some notes if you like. I'm not gonna be picky about this. I just want you to practice using your Notice how we have our manipulators. So you may have to go into Tools Options and go into, let's go ahead and go to Tools Options. Okay, let's go to Tools Options, see if we have access to FTNA. Oh, it looks like we don't have FTNA. Oh, here it is, Annotations. So go into Infrastructure. Here's Annotations Infrastructure. Click on it. And you want to go into Manipulators. And you want to make sure you have these on, these manipulators, so you can manipulate your. Okay, so let me go ahead and turn all of them on. See if I didn't miss anything here. Okay, it looks like we got all the manipulators. And okay. So by turning on the manipulators, I have access to manipulate the text, as you can see. All right, so another note I'm going to use is the general notes. So let's go ahead and add general notes. It doesn't matter which view frame. Oh, I hit enter, so I exit it. Let me go back and double click. Hit control enter, so it'll go to the next line. Let me start over. I overwrote general notes. Control enter. Okay, node 1. Let's say node 1. I'm just making stuff up. Do not paint. Do not primer. That's a common note where you want surface to surface contact. Bare surface to surface contact between this part and another part. Control enter to go to the next one. Note 2, I'll just type in note, anything. Again, we're using capital letters. Control enter. Another common note is once again the material. So we'll just make this part out of aluminum. Control enter. I'll call this note 4. And I'll say this time I'll use 7075, which is a very strong aluminum alloy. 7075. Typically in aerospace, when you're machining structural members, we go with the higher strength aluminum alloy, 7075. And the temper, I think T651 is a common one. The temper can be the aging of the material or the treatment of the outside of the material, how it's treated to be aged. Think of putting a Quizno sandwich in the oven, right? If you go order a Quizno sandwich and they run it through and they heat it up, it makes it stronger, right? Okay, so if we have 1, 2, 3, 4, 5, 6, 7, 8, so we'll just add 2 more notes and we'll be done. Okay, so if I wanted to go back to the side view and add more notes to the side view, double click on it. So now the frame is red, and I'll just add some random note. The other side, I'll just call it note. So that's 9 notes. And let's add another note. This time we'll do one at the bottom. And again, we'll just type in note. Okay, so we have a total of 10 notes, and that'll give you your 100 points for this assignment, 100 out of 100. All right, so and to end this lecture, we're going to do another scene, something we learned in the previous lecture, in the drafting lecture. Okay, and notice also in scenes, we also have captures. Just like the captures we did with FTNA, you can also do captures of your exploded views. It doesn't have to be an exploded view. It can just be an altered view. Maybe something shown in an open position versus a closed position or stowed position, for example, versus a deployed position. Good example are satellites. So space satellites, when it's launched, it's in the closed position. And once you open things, once it's out in space, it's going to open up in the deployed position versus the closed stowed position. All right, so let's do a quick scene for practice. Okay, and don't forget to save your work on the clamp strap. You can, if you want, you can save it with a different name. If you want, you can just save it as is, clamp strap. Or if you want to save it as an FTNA, if you want to save a clamp strap FTNA and save it, go for it. Okay, so let's do an exploded view. Let's go to this time I'll use a clamp assembly. I'm gonna close it. So I don't want to save all this stuff. Same thing with this one. I'm just gonna close it. Make sure you save it. I'm not gonna save it here. All right, so I'm gonna go ahead and open up the clamp assembly, and I'm gonna do an exploded view. Create a scene. Oh, it still had all this stuff saved in the background, unfortunately. It's okay. I'll go ahead and do the exploded view on this with notes flying all over the place. I want you to notice that I'm missing the hook clamp. And the reason I'm missing the hook clamp is because I renamed it before opening CATIA. So I'm going to go to Edit Links. Let me go to File Desk, and it'll show me my links also. File Desk. And it'll show me any bad links. So here's the problem. That hook clamp, this is a part number that was assigned to it, and I renamed it hook clamp. So let me go find it. And here it is. I had renamed it hook clamp. That's why I couldn't link to it and open it. Okay, and there it is. It's linked. So now when I go to my 3D model, it'll load the hook clamp. All right, so let's do an exploded view for fun. Okay, so make sure you dig out in the part design assembly workbench, make sure you dig out your scenes toolbar. I'm hitting the shift key as I move it to change the orientation to horizontal. Okay, so let's create a scene. Go to scene, I'll automatically allow it to give it any name. Okay, so using your compass, you can go ahead and randomly move stuff. It's not going to affect your constraints or your assemblies or sub-assemblies. Okay, so typically you'll do an exploded view so you can see all the components, especially all the hardware that's hidden in there. And if you were wondering, this has nothing to do with FTNA. I'm just reviewing how to do an exploded view. So you don't have to continue on with this video if you don't need to see this exploded view demo. Okay, so we do exploded views to expose all the hardware that's hidden. All right, so if I'm happy with this exploded view, then you give it an orientation before you exit. So I like this orientation, okay? So then you can exit. And once again, you can also do captures in scenes. Okay, so I'm gonna go ahead and exit. Okay, let me reset the compass. You can see the compass is still active. So let's go ahead and reset compass. Go to View, Reset Compass. And now I can go to my drawing and I can insert that exploded view. Okay, so let's go ahead and insert an ISO view. Okay, so go to isometric view, insert an isometric view, go to your assembly. And from the tree, you're going to pick the scene that we just created, right? Scene 1. Click on it and then click on any flat surface to generate the view. Okay, and there's my exploded view. I like it. So let's go ahead and generate it. There it is. Obviously, this is too big for the sheet, so I can always change the size of the view. Go to right-click Properties on the view frame, right-click Properties. Yeah, I'll make it 1/4 the the size instead of full scale 1:1. And OK. And there's my exploded view. And once again, if you go back to your exploded view and move things around, this view will update. Okay, so, and just a reminder, after this assignment, all we have is digital mockup, where we do a clash analysis and a section cut of an assembly to analyze it to make sure nothing's clashing or a part is not buried into another part, for example. Okay, and this is something you can do in 20 minutes, and this will be the last of our assignments, which I'll discuss in the next lecture. End of lecture.